This is my fourth video lesson for the unit Atomic Theory. Today we're going to talk about how are the electrons arranged in the atom. So let's go to page 13 in the class packet. Motivation. Looking at the reference table, the periodic table that is, what is the maximum number of electrons in the first energy level of an atom? Also check the second energy level. So take a moment to do that. Once you've done it, resume the video. Learning target. At the end of the lesson, I will be able to write electron configuration of an element and identify the ground state of it. For announcements, just do homework number 4, which is a Juno pod. So this is a quick recap of what we've learned so far. So this is an atom. In the center is the nucleus, which consists of the protons and neutrons. The electrons are on basically the orbitals or shell or energy level. The regions does not make a distinction between these three things, but there is a difference between an orbital and an energy level, which I'll discuss later on in the course. So check of understanding, what element is this? So since we're given an atom, we assume it is neutral, right? If it's neutral, protons equals electrons. And since there's 3 electrons, there must be 3 protons. So the answer is lithium, Li. So if you did the motivation, you should be able to figure out the maximum number of electrons of the first and second energy level. They are 2 and 8. For the third and fourth energy level, they are 18 and 32. So you may have noticed on the periodic table for the third and fourth energy levels of the larger atom, there's something weird going on. Notice that it does not fill the third energy level completely before moving on to the fourth energy level, okay? There's a reason for this. I'll explain this issue later on in the unit. But, just to be brief, it's because the regions does not make a distinction between orbital and energy level, all right? So the reason why the regions does this is so it'll be easier for you to understand bonding later, all right? So this electron configuration is not really that accurate, okay? But it's very easy to use to explain and do bonding later, okay? So I will address this issue later on in the unit. Check of understanding number 2. Which energy level is filled first? The one closer to the nucleus or the one furthest away? So here is a picture. So you might guess it's the one that's closer to the nucleus, all right? So remember theme number 2, opposites attract, okay? So you're going to fill the inner energy levels first. Then you're going to branch off from there. Learning check number 1. Which principal energy level shell can hold a maximum of 8 electrons? Pause the video and resume once you have the answer. Okay, so the answer is choice 2. Learning check number 2. An atom of which element in the ground state contains electrons in the 4th principal energy level? So try to do this yourself, pause the video and resume once you're done. Okay, so here's the answer. The answer is 1. You did not need to know what a ground state is to answer this question. If you look at the periodic table for krypton, it has an electron in the 4th energy level. Learning check number 3. An atom in the ground state has 2 electrons in the first shell, 6 electrons in the second shell. What's the total number of protons in the nucleus of this atom? So try this yourself. Resume the video once you're done. Okay, so atom is assumed neutral. Okay, so the protons equals electrons. So we have a total of 8 electrons, so there must be 8 protons. So choice 4. Check of understanding number 3. Which electron has more energy? The one in the first energy level or the second energy level? So pause the video and think about this and resume the video once you have an answer. So the answer is the second energy level. So why would the electron in the second energy level have more energy than the electron in the first energy level? So the way you could think about this is to think about the potential energy of the electron. So here's an analogy. Let's say you're holding a soccer ball and you're going to drop the soccer ball to the ground. So the soccer ball that's higher up from the ground is going to have more potential energy than the soccer ball closer to the ground. Okay, so the same logic. So imagine the ground to be the nucleus, and these are the electrons, right? So the electron that's further away has more potential energy than the electron that's closer. Well, this is going to be important later when we discuss bonding on why the electrons in the outermost shell are the ones that are going to participate in bonding. The reason is because those electrons have more potential energy. They're more likely to do something than the inner electrons. So just to summarize, okay? So the energy, right, of the electrons will be greater for the outer shells than the inner shells. Learning check number 4. Which statement describes the relative energy of the electrons in the shells of a calcium atom? Pause the video and resume once you have the answer. Okay, so let's go over each choice. An electron in the first shell has more energy than the electron in the second shell. So that's wrong. An electron in the first shell has the same amount of energy as the electron in the second shell. That's wrong. An electron in the third shell has more energy than the electron in the second shell. So that's correct. An electron in the third shell has less energy than an electron in the second shell. That's wrong. So the answer choice is 3. Okay, this is what we just discussed. Electron placement. So this is a summary slide. So electrons always occupy energy levels in an atom. So each energy level is further from the nucleus. Theoretically, an atom can have infinite amount of energy levels. The lower energy levels are filled first. Each energy level has a maximum number of electrons it can hold. The electrons further away from the nucleus have more energy than the ones closer to the nucleus. Okay, nuclear charge. So nuclear is referring to the nucleus. So basically, nuclear charge just means the charge of a nucleus. So what does the nucleus have? The nucleus has protons and neutrons. Neutrons have no charge, but protons do. They have the positive one. So nucleus is always going to be a positive charge. It's going to equal the number of protons. Okay? So here we have carbon. Carbon has 6 protons. Therefore, the nuclear charge of carbon is 6. Aluminum have 13 protons. So the charge of the nucleus for aluminum is 13. So what is a ground state? A ground state is the electron configuration listed on the periodic table. This is the ground state of the element carbon. In a ground state atom, all electrons are placed at the lowest possible energy levels. Okay? So the total energy of the electrons cannot be lowered by moving one or more electrons to different energy levels. So if you were to move electrons around, it will not lower the energy of that ground state. The ground state is the lowest possible energy state. It cannot get any lower. Okay? Learning check number 5. Which element has a ground state configuration of 2-8-1? Pause the video and resume once you have the answer. Okay, so you just go to the periodic table, you look up the electron configuration, that'll be sodiums. Using your reference table, write the ground state configuration of lithium, argon, hydrogen, and calcium. So do it yourself, pause the video, and resume once you have the answers. Okay, so here are the answers for lithium, argon, helium, and calcium. So you may have noticed for the larger atoms that the first 2 energy levels are cut off for some reason. The reason for this is because the full electron configuration could not fit into this small box, okay? So notice there's a star here. It's referring to this star on the bottom of the periodic table. It denotes the presence of 2-8 for elements 72 and above. So I'm just letting you know. So this concludes the video lesson for today. You can do more practice, like drawing the models of each atom, as well as the regions and SAT2 practice questions on the next page. So remember to do the Junipod homework.